The following presentation was recorded at the 2013 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2013 for helping make these videos possible.
Well, hello. Thank you for all for showing up. Continue coming on in if there's more interest. Also, there's seats up here. If anyone wants to sit here behind me, I will ask that you perform some live demonstrations for us. So again, don't be afraid to take these chairs. Do ask questions during the talk. We'll worry about pacing and all that junk as it goes along. I might delay if you ask a technical question because, again, we cover a lot of material in here, so your question may be answered a little bit later. And then as a practice, since I'm holding the mic, if you have a question, please remind me to repeat the question so that everyone is on the same page as we go forward. So a long time ago, I'm going to start with a short story about why I love investigating tools. A long time ago, 10 years plus, I was asked to set up a change route in a hosted environment. So I go on there and I start messing around, and I'm not quite getting it. And it's the end of the day, so I stop and clean up my work and then go home. And I go out with some friends, and I'm drinking beers, and I won't name the count of it, but I get a call saying, hey, this thing is broken. It's not working now. Well, when I had cleaned up, I had done an RM-RF, and there's a difference between a relative path and an absolute path. But I had the option at the time to clean up, since we had dual hosted and gotten two machines, a quick little SSH command, save the bacon on that. So as I present this, I ask myself, well, why do we want to learn all this stuff? It's not just fun, although I get quite a bit of enjoyment out of it. Knowing your tools and knowing the versatility of your tools it's helpful. It saves your bacon. So SSH, we're here to talk about SSH. When you ask people, they say SSH is remote access. This is true, but it's subtly true. Most people hear SSH as secure remote command line access. It does that, but that's incredibly limiting. As we go through, there will be examples on the screen. There'll be some fun scenes as well. As you're watching what's on the screen, let's try not to nitpick the details, because there's OS differences, there's version differences, there's daemon configurations that have to happen on one end or the other. So try and learn, try and imagine how this stuff is being used, but your mileage may vary as you implement. Also, just because it has secure in the name, it's not magic. As you watch the slide, please be skeptical about what you're seeing and how it's working, because, again, it's not magic, and also, it's Unix. It gives you all the rope you want to hang yourself. So here's a very basic example. Is that clearly visible to everyone in the room? The darkness isn't. Can we turn down the lights just a little bit? Can we turn down the lights for visibility? I'm not sure where the controls are. It's Mac Air, but simulated. So is that a little bit better? Eh? Okay, well, I'll describe, and then they'll continue to work on the lights, and we'll see how far we get. We've got a basic SSH command here. We're sitting on host A. We go to host B. It asks for a password. We type that in. Voila, we're on the command console for host B. This should be very familiar to all of us. Again, host, password. Hey, we do this, we do that. We waste some time. We run something else. We leave a mess. And we exit. However, if we've got something where we just want to do one command, we can do that efficiently. We can tell SSH to do that one command and that one command only. For example, fork while fork. It's a fun little command. However, don't run it on a friend's computer. So you've just run along, you've done something nifty and said, well, crap, I'm on the wrong machine. Very simple. Tell it to do the same thing on the right machine. And this is some bash command going on. We've got the double bang gets interpolated on the command line to the complete command at the bottom. It's now happening on the right machine. Another example, you like Wireshark. You like working remotely, but for some reason you don't have a console VGA cable 15 miles long to get to that machine. So can we work on Wireshark remotely? Yes, we can. We can do this with the simple -x command. So SSH-x will take user at host command line. We've X-forwarded the daemon from X11 on the remote machine, and we've opened a terminal on this machine. It's subtle, but as we're on host A to the left, to the right, well, I guess that is your left, we'll see that, hey, everything we enter in that command, even though we're typing it on a local machine, is kicking off on this machine. So if we wanted to, we could enter Wireshark right there. We get that magic happening for us. But we have other options. And this is important because, as I note, Wireshark may not be installed on the remote machine. A visual desktop may not be installed on the remote machine. Or doing all this may be kind of slow. So how would we go about doing this remotely? Input redirection. Here, we're running that one command, sudo tcp dump, and then we're piping that back to our local machine. SSH host, and then everything inside singleticks is passed to the remote machine. The pipe brings it back and starts feeding it to Wireshark on our machine. I made a note earlier about being careful to set stuff up. Right now we've got our TCP dump saying not port 22. Why would we not want to go ahead and capture the traffic on port 22? Exactly. We're going to get a lot of spam because every time we're monitoring a packet on the remote end, it's passed to us, and we're also monitoring the packet being sent to us, so we get a giant feedback loop that's just going to spin up your screen. Also, sudo is normally going to ask for a password, so you want to go ahead and configure in vi sudoers, no password, or some other measure so that this will kick off nicely for you. Can we send a command to multiple machines at once? Well, probably. We can do a for loop. Nice, bash, simple. Hey, list our hosts, go on from there. It's iterative. It works. We can have some more fun. We can try it this way. More input redirection magic going on. We've got the T command spinning. Again, on the left, we've got the T command spitting that to 3 different machines. That greater than in parentheses is pipe file input redirection, except it just happens to be kicking off a process to accept that redirection rather than dumping it into a file. The P utility is available in lots of places. More utils package is the Red Hat version through EPL, I believe. But it does the same thing that T does, except instead of writing to multiple processes, instead of writing to multiple files, it writes to multiple processes. The syntax is far easier to remember. You don't have to remember that greater than parentheses unless you do that magic all the time. But this is ad hoc. There are plenty of packages out there that are going to do this for you automatically. P shell, PD shell, cluster shell, all great tools. I will caution you though, if you find yourself wanting to do administration in this way, you're running on one host, you want to send the same command to 15 hosts, 1,500 hosts, you probably want to stop and reconsider your infrastructure because this is very ad hoc. Right? So you issue one command and then you forget about it a couple days later. There's better tools out there. There's Puppet, there's Chef, there's CF Engine 3, if you like that. There's SaltStack. There's plenty of opportunities here to build infrastructure that configures itself and is administrated from one place in less of an ad hoc manner. That being said, this stuff is useful in a pinch. A note about PD shell. I was talking to a friend about presenting the slides, and he says, yeah, PD shell is awesome because it'll scale to 10,000 machines. That's not something I encounter in my day job, but may be useful to you. So what else can we do with input redirection? A fun little trick. Take a sound device, pipe it to a remote machine, play it out on the remote speakers. Wow. Talk to the wife in the kitchen, scare the bejesus out of her, maybe scare the kids, maybe scare the colleagues. But that's a simple idea. It's a fun idea. Simple redirection again, dev SRO, the CD device. We dumped that to an ISO file on our local machine. Hey, that's kind of nifty. We can image machines remotely. Also, if you don't want to store it there, all of a sudden it's bound in one step. The same idea here, dev SDA. That's our local hard drive image on a machine. Here I just happen to be taking this machine and dumping it remotely. Conversely, if we wanted to do the SSH and the DD inside, we could go ahead and grab that remotely and dump it on our side. But the advantage of this, of course, here I'm using an example of grabbing our forensic image, but also, much like with the port 22 traffic, here we're grabbing an entire copy of that disk. Well, if you're grabbing an entire copy of the disk and writing it to that remote disk, well, you're changing what you're writing, so it's going to be invalid. So it's a great way to grab a clean copy. So we've done lots of 1Z files and 2Z files. One file. Hey, 2 files. Here we're using input redirection and tar to go ahead and get all those files on that remote location into ours. And we're unzipping it on our side, so we're not just creating a tar file on our side. We'll go ahead and putting it in place. This is nice. This is preserving permissions. It's zipping in it. Excuse me, it's not zipping it in flight. You could zip it in flight if you dropped in a J or a G on the tar commands. But SSH will do it for you. SSH can do it in a couple ways. The first one here is just dumping it into the home directory, wherever that is, on your machine. The second one is renaming the file. The third one, putting it in a different directory entirely. Or, hey, we can even recursively copy directory. This is all very well and good, but you kind of have to know what you want and where it's at. We can do this interactively with SFTP. Alternatively, and of course our tools give us options, we could try rsync mixed with some SSH action, or even SSHFS. SSHFS is an interactive package. It actually pretends to mount that remote file system directly on your local machine, so you're operating on it just like you would anything else. So what about doing all this fun stuff on schedule? Why would you want to do it on schedule? Save yourself a lot of time, get it done automatically. Perhaps you're generating some log files remotely. You need them here for processing. Remote audit copy, something like that, just because maybe they're getting overwritten automatically and you need to stash a version at a time. Can we do it automatically? Yes. This crowd knows how. And here's the command for that. So grab a file from B, drop it here. And we got that going on. Hey, look. Day 1, the directory's empty. Day 2, oh, it's still empty. Day 3, it's still empty. Day 4, it's still empty. What did we forget? No passwords, right? So we set this job up. First thing it's going to ask for, hey, what's the password? And we didn't enter it. So let's see if we can do this without passwords. We can. It's called public key cryptography. SSH has a little tool for generating your keys, SSH keygen. Walking through that process, SSH keygen-f foo, enter passphrase. We hit enter, so there's going to be no passphrase here. Hit an enter again. Says the private copy, your identification has been saved in foo. The public key pair, the public key part of this pair is saved in foo.pub. Gives us a fingerprint and random art. The random art and the fingerprint are for validating that the key you're working with is the one you think you're working with. So this is a quick way, instead of comparing that long string, it's just a quick way of seeing, hey, comparing 2 keys, am I working on the right one? So now that you've got this key pair, how would you use it? Foo stays local. Foo is always yours. You never share foo at all. Foo.pub goes on the remote machine. You place it on the remote machine. Here we're using SCP. We go into that machine, we go into the .ssh directory, and we copy the contents of that public key into the authorized key file. That simple, right? 5 steps? Yeah. Or, since we've already learned our SSH foo, we can do it in one step. Hey. So one step, here we go, but hey, there's an even faster way. There's a utility, SSH copy ID. SSH copy ID is going to ask for your password because the key's not there yet. Once it asks for the password, it puts the key in place. There we go. And now when we log in, magic. So this is where we started. We come back. Hey, now it's working. It's fairly trivial what it's doing. But again, as I asked with multiple SSHs, is this really what we want to be doing? This is really the perspective of the machines. It's getting a command from another server, and frickin' magic is happening. So it works. You understood it when you typed it up. You understood it when you hit enter. You understood it for the next 12 hours, and then you forgot. And when you come and try and fix it later, this is what you're dealing with. This is a lack of documentation. So if you are going to set up remote jobs and remote SSH actions, document them. I'll also note we've set up this SSH key without passwords. Well, all of a sudden, we've left the keys lying around. Maybe you've got an NFS-mounted home directory. Probably don't want to leave the keys sitting on the front porch for the burglars to come up to the door. So be careful how you use the keys. What's the right way of using keys? What's the more cautious way? Well, one thing to do is SSH agent. Now, a caveat, SSH agent, the way it works, you start it up in your local terminal session. You type in a password. It remembers the password for the keys you have. You go on from there. You never have to really type them in again unless you start a new terminal session or whatnot. So this thing remembers the key for you, so you don't have to. That's great. cron doesn't interact with SSH agent. So really, passwordless keys, they're useful. You still need them. So is there anything else we can do? Yes. We can try forced commands. What happens here is on the authorized keys, when we put that on the remote server, we specified the only thing someone with that key is allowed to do. If you are interested in exploring the true power of this, Ghetto Lite is an SSH package. Or excuse me, it's a Git package. And it uses SSH keys for all its action. Git, by default, lets you pretty much manipulate anything you want to on a remote repository. Ghetto Lite separates those repositories so that you can have individual directories for different projects. You can host this in a corporate environment so Team A can access the right stuff, Team B can access the right stuff, and they're not interfering with each other. But it's, again, Ghetto Lite's marvelous. It just works through SSH keys. It's a great package. It's a really great example for seeing some fancier stuff to do. Let's look at a lockdown example. I mentioned rsync for file copies before. Here we're doing it. We've got a cron entry on machine mirror, and it's going out and it's picking up this ISO archive on this other machine. So it kicks off rsync, avz, delete, source, ISO archive, and then it dumps it locally to archive/ISO. On the source machine, our authorized key file, what it's letting it do is rsync --server --sender, whole bunch of options, dot, local, ISO archive. And then it's got some other stuff disabled, and then it's got the key. The point here, the commands are completely different. So the rsync on the mirror is completely different than the source. How do you deal with something like that? This is troubling to set up, but the trick when you're working with something like this is to use SSH-V because it's the verbose mode. You can actually use multiple V's if you want to, but you only need one. With one V, it gives you the debug level 1. It tells you exactly what command you're sending. So then it's very easy to cut and paste. Still takes some fine-tuning, but you can then take that version of the command that needs to be executed on the remote side and put it in the right place. What else could we do with this command stuff? Well, hey, look, we're back to input redirection. Anyone who connects to this particular log cabin machine, date gets dumped into the log file, and then cat gets dumped to the log file. We've not specified anything for cat, so it's going to pick up standard in. Well, standard in gets dumped in, so effectively anyone that connects to log cabin gets to write whatever they want on this remote directory, gets date stamped. Hey, maybe this serves as some sort of remote logging facility for you. I'll note whoever connects issues command. It's not that, hey, they're allowed to, if their command that they've issued syncs up, it's no. Whatever they connect with, however they connect, command is run. So in our instance, we're dumping the log, we're catting the log, but in the previous instance, we're using rsync. So every time it connects, even if we've not issued on rsync command, this rsync on the remote side, so we connect, it starts dumping all this information to us. So it gets spammy. Here, the two commands know what they're talking to, but if we had tried using this key to connect with something else, we would still get the rsync output, so it gets kind of spammy. We wouldn't be computing if we didn't have a config file, would we? So let's look at a good config file to mess around with when we're doing this stuff. .sh/config. We've got 4 entries in our SSH config file. We've got some random stuff going on. It's just great to stash it away, commonly used stuff. If I'm always connecting to my machine, tick, I can specify that. I get this username. It goes on in. I've saved myself a lot of typing. If you start messing around with this, the caution, the caveat about working with this is that it evaluates first every host entry that matches. It does this in order from the top down. And then each directive that it receives inside a host gets set, and it never gets overridden. So for example, we specify host splat, forward agent yes, permit local command yes. But in that in that bottom stanza, we've got a machine in the 172.28 range. If we were to connect to a machine in the 172.28 range, say 172.28.1.4, the splat would get hit first. The forward agent would get set to yes. Permit local command would get set to yes. And then the intent, evidently, is for machines in the 172.28 is to get permit local command no. That would not get overwritten. That would still be happening. So if you're having trouble messing around with all this stuff, get it working. It just doesn't override. So be careful how you fill this thing out. You may try to set something up for security, and it may not be happening in the correct order because your splat's at the top of the file. So word of warning there. We've talked a lot about what we can do on the command line, what we can do automating. All this has been, hey, we've done stuff over the network, but we've not really done anything to the network. Are we at least at this comfort level of networking before we move on? Okay. So here we've got a local forward. We've got host A sitting up top. We want to get to host B. TCP 5900 is what's listening on host B. That happens to be VNC, remote desktop protocol. So we issue the SSH command. Let's go to host B. Let's do a local forward for port 5900 on our machine. And we're going to pick up, and the source of all this is going to be localhost on the remote side, 5900 on the remote side. I'll very clearly point out everything to the left of that first colon is happening on our side. Everything here and on is happening on the remote side. So the remote host is interpreting localhost and connecting to itself. So pictorially, we have that happening with this little arrow, and we see that TCP 5900 is now listening on host A. Hey, look, 2 jumps. And we've just done the same thing twice. Hop, hop. Hop, hop, hop. Now, this is incredibly convoluted, but it sort of works as an example because what happens when we start having firewalls in the way? What happens when we have different routing in the way? I kind of foreshadowed with my statement that we can simplify. We can simplify it saying, hey, instead of listening localhost 5900 on B, which we're instructing B. Let's go ahead and pass that traffic on to C. And so here all of a sudden we've got one command. It's nice and short, and then the host on host A, port 5900, is now listening. It passes all that traffic on to host C, 5900. It just happens to be doing host B. We've got this big fat green arrow. This is the encrypted part. This is the traffic that's actually being protected. So the previous example with hop, hop, hop may seem a little bit contrived, but it would have had fat green arrows along every step. Here, as soon as the traffic gets to host B, it's not being encrypted anymore. SSH daemon on host B unencrypts the traffic, passes that on raw to my remote host C. Here we're remapping port numbers, very important. Just because anything under 1024, you're not going to be able to do yourself. So maybe you want to mess around with sudo, probably not. Probably too much hassle. So let's go ahead and just map it to 8443. And now our web browser, we can look at that SSL traffic on our local machine, and there we go. Here we're doing multiple port forwards. 3 machines. 3306 is MySQL traffic. So host A now has 3 ports open, 3306, 3307, 3308. It's all being passed to host B, which is then forwarding it on to C, D, and E. Yeah, this works. It's kind of annoying because you have to go in and specify your MySQL client to connect to 6, 7, and 8. Got an arrow there. Yes, that's the part being secured. The rest of the traffic is not. I'll also note, to the perspective of anyone trying to watch our traffic, we're going over this one connection between A and B. So if you're worried about eavesdroppers, then all of a sudden it looks like one stream. They can't tell the difference. Also, if you're trying to open a firewall port, it's only one port. So if you know you're going to a remote administration example, then all of a sudden, hey, you can minimize what you're doing. Pop quiz time. How many IP addresses on your local machine? Just 2 NICs. Well, actually, no, just 1 NIC. How many IP addresses? You said... He gave me the cheap answer, 2 or more. How much more than 2? Entire Class A. Congratulations, the man wins a prize. Yes, we do have the entire Class A here. Localhost 127001, Linux will respond to every single address in that range. This is useful. This is useful because I've been cheating heretofore. There's actually 4 commands. And the first one has just been assumed all along to be localhost. It doesn't have to be. We have an entire Class A to play with. Class A is 16 million addresses. That's quite a bit of playground. So here, instead of typing MySQL localhost and specifying this port to connect to, we can go in and we can manipulate the port number, or excuse me, the IP address that we're connecting to, and continue using the same port. This is convenience. I'm a sysadmin. I do this multiple times a day. I like convenience. I'll also note localhost is simply an alias. So whereas previously we were just saying localhost, it actually does map to 127.0.0.1. It's an etc host. So if we look inside etc host, hey, we provided an alias from localhost to 127.0.0.1. Let's provide some others. And then all of a sudden, since we've changed the port numbers, those now have aliases. We can use the aliases, same port number, and connect all this other stuff. And my MySQL command is now very simple to type. I'll also note I keep the generics local 2, 3, and 4 available. I'm using this for 2 hours at a time. I can keep those names straight over the course of 2 hours. If I'm a DBA administrator that's connecting the same machines constantly in and out, then I can use the bottom host names, and I've got joking names there, but you can give them local dash payroll server, local dash financial server, local dash customer server, and you get through your firewall and you keep things sane. Conan and I happened to agree on this. This is my favorite thing about SSH. Too dark. Oh, well. So we've done local forwards. Can we do it in reverse? Yes. and R stands for remote. We're bringing that remote port back here and opening it up. So on the top, on the left, we've got the home machine. It's listening on 22. We go into the work machine, we issue that command, and then all of a sudden, the work machine's now listening on 2022. That traffic gets passed back to our SSH daemon. So that in action, same command. Now we're at work later, and boom, this is what happens for us. Later at work, we connect to the local machine 2022, which we've opened, and now every time we connect, hey, we're actually opening up the machine at home. I mentioned Auto SSH is a convenient tool. It's going to monitor SSH connections and reopen them. So if you're doing port forwards like this for your convenience, Auto SSH is a tool you want to investigate to make sure those are always up and always available for you. I'm sorry, was there a question? I know there was a sneeze. I didn't know if it covered anything. So what happens when we forget and we're halfway through our session and we said, oh yeah, I really need a forward right now? Well, you can use ~C. Tilde is the escape character that can be overridden. But ~C, it opens up this little SSH prompt, and we can specify a new local forward right in the middle of our action and then continue going on about our business. It's kind of nice, especially if you want to keep history and context and all that other stuff in place. What else can you do with the ~C action? Well, permit local command, which I had specified in my .sh/config example earlier. Permit local command action is right here. I can prefix on the SSH prompt, I can preface a command with bang, and it does that command for me. It spits out the result, and then I've got that. I haven't cleared my session. I'm still on that remote machine, but I've gotten the results of that one quick command, much like VI. If you've ever used that feature in VI where I'm writing along, I'm doing my coding, I need to go back and get something, boom, there it is. My favorite trick here, SFTP. I'm operating on this remote server, I'm doing all my action, I've bundled up some files. Oh wait, I really need to save these off system. So SFTP, grab those files, bring them back, go on about my business. We've done local forwards, remote forwards. Now we can actually open up and write directly to a remote port. This is much like Netcat in action, except Netcat doesn't encrypt for you. So, boom, -W, connect to the machines 25, and hey, we connect. I happen to be doing this because I don't want to, I've got 25 here, that's mail, right? This is a controlled place where I know I can send mail in safety, especially when I'm using examples like this. So I've got a file here, it's just got a mail template. Hey, let's have some fun on the network. And we can just feed it in. And then of course the forward goes ahead and connects, reads everything from standard in through the pipe, writes it to that remote port, writes it to 25 in our example. And then we see the acknowledgement of the mail daemon saying, hey, yes, your boss now believes you need a raise. So earlier we were doing this to get 443 traffic, SSL traffic. This example also has 80. This is useful, but it's not really comfortable, right? Because you've got to specify, you've got to know what machines you want to connect to at a particular point in time. You still got to remap the ports. So it works, but it's awkward. SSH also gives us dynamic forwarding. Dynamic forwarding takes a little bit more example to set up, but you go into your web browser. This is Firefox. You specify for the SOCKS proxy localhost where it wants to connect to, the port it should be using, and then do your web browsing traffic. All your traffic in that web browser is now being carried from your work machine. It's passed through your home machine and then on out to the World Wide Web. Don't tell your security guys you're doing this. They kind of like controlling what websites you're visiting. Everyone should be able to browse 4chan at work, right? This is their perspective, by the way. I said a work example. You can also do this as a cafe. -P specifies the port that SSH is connecting to. So here say you're at a cafe, you now connect to, you set your SSH daemon up at home to listen on 53. Cafes generally don't block 53 because they need that to redirect your web attempts to their login page to say accept. So this traffic is going to pass on by, and voila. You're now using their open internet for your own purposes without having accepted their terms. You're stuck in a desert. You may not be able to use this magic O, but yes, you can. Putty, of course. Putty Tray does some SSH features. Kitty's kind of a rewrite of Putty. It's pretty nice. Sigwin, give yourself the whole Linux environment right there. It's good to go. WinSCP, actually, I will say they've done SFTP right. It's nice and graphical. It's all that fun stuff. But while it's stuck on Windows, nobody's ported it yet. So if you hear about that, please let me know. So thank you for listening. I appreciate the crowd. What happens when you want to go and learn more? OpenSSH.org. It's great. They do have biannual releases. The release notes are dry, but they're chock full of good information. -W, they announce all this stuff here. It's one of those tools that I like talking about because I think it's extremely versatile, but nobody has release parties for SSH. So go out, check out the information, and go on from there. Questions? Comments? Fun stories? Yes. I'm sorry? Yes. The slides are available online. X47 Industries, there's a presentation section. The slides are available now. I've not updated them as of this morning, but that is happening in 15 minutes. Anyone got a wonderful story about SSH saving their bacon? Yes. Yes. So the question was, he's used Putty. He's made the ports accessible from more than localhost. I'll pull up a slide. No, that's... Yeah, we use this one. So here, we're doing a local forward. We're specifying localhost. We don't have to. We can specify any address we want to. We can specify our public our public network address. So all of a sudden, here we're using localhost 127.0.0.1. It's private. If we had specified our public interface 192.168.1.14, anyone on the local network could be using our traffic. Start your firewalls, boys. Thank you. So yes, you can make the traffic available. You can also do this remotely. And again, your security team likes you less for that. If you had specified -R instead of the L, then you could bring a port from that local machine and open it up on your local network. Anyone on your local network could then share that tunnel as well. Question? I'm sorry, DNS? The question was, he's heard that DNS is not secure, speaking over a bound socket like that. Alas, I cannot speak to that. Any context on that? Get that, okay. Let me pull up. The very prudent comment was, if you're doing a dynamic forward like this, then all of a sudden people still know what you're doing because DNS is not actually going out your traffic. So all of a sudden all your web requests, well, before you actually initiate a web request, the first thing it's going to do is ask, well, what IP am I talking to? And who's it going to ask? Well, it's not asking SOCs, so it's asking the local network. Your local resolvers are picking up all that traffic information. So even though they can't stop you from going to 4chan, they still know you're going to 4chan because you've made that local DNS request on your local network. The best thing I can imagine to do for that, I don't know of any tunneling services for DNS, but you could always Etsy hosts. You can tunnel DNS through SOCs. It's a setting in the browser. Excellent. Awesome. So you can tunnel DNS. Awesome. If you do get crazy with tunnelings, I will note, though, that UDP is generally not easily tunneled. These are all TCP ports that we're forwarding and intercepting. So there is some manipulations, and I don't have any prepared slides about it. There are some manipulations you could do. Set up Netcat, listen to a UDP port, tunnel that traffic to a file. All of a sudden, because you're now reading and writing to a file, you can use SSH to forward that. But again, that's left as an exercise to the reader. Questions? Favorite stories?
We started playing with SSH a few years back, and we actually had a lot of fun hacking each other with it. It's a lot of fun. We'll make the max say things at any time, and time goes out. It helped us out a lot in our team because we have a rule that we can't hack our users. So we can't set any member of IT can be hacked at any time, and if you're not smart enough to stop it, then that's your problem for you.
Vicious work environment, but I like it. Sounds like fun. Yes. Yeah, that's pretty fun. I was reading Reddit this week, not at work, honestly. My boss was in the room. And their story was, hey, entertain your cat with just eject-t, because that'll toggle the remote device. So yeah, you could dump that through SSH and do that remotely. Set up your webcam just to record that kind of action as well. So yeah, lots of fun there. Well, thank you all very much. I'll be here all weekend if you have any questions. Thank you.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and the administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HDIP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source. The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and then fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how Cloud Stack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of Cloud Stack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you will you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
Cloud Stack is a robust solution for large deployments. You have dozens of data centers and thousands of servers in each data center. These hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.
Most enterprises today realize that usernames and passwords alone aren't enough to keep their network safe from unauthorized intrusions. That's why two-factor authentication has gotten so popular lately. It adds that extra layer of protection enterprise networks need to stay safe. But what you may not know is that some two-factor authentication solutions, they're better than others, like two-factor strong authentication with Wicked. Wicked goes beyond other authentication systems by being less expensive, easier to implement, and easier to use, giving you software-based token clients built to run on all major devices and OSs, including iOS and Android. These tokens utilize a public-private key combination that's generated on device, so there aren't any shared secrets flying around for attackers to hijack, or which require any special handling. Instead, all keys are kept secure and private between the requesting token and your server, which you control in-house, making it the most secure way possible to perform authentication encryption. And with an extensive, flexible API and support for protocols like LDAP and Radius, Wicked works with any enterprise network architecture to protect the IT systems vital to your enterprise. Download your Wicked free trial today, regardless of whether you're considering two-factor authentication for the first time or just ready to ditch your existing expensive key fob system. We can help with easy-to-implement, easy-to-use, strong authentication from Wicked.